Hi everyone, let's talk about today's LeetCode daily challenge. It's an interesting problem because it has two solutions, at least as far as I know, or more. And I like problems that have multiple solutions because you are not confined to just one way of thinking. You can think about different approaches, and that is creativity. So let's take a look at the problem. You are given an integer array heights representing the heights of a building, of buildings, and you have some bricks and some ladders. You start your journey from building 0. So you are always starting at building 0 and move to the next building by possibly using some bricks or ladders. While moving from building I to I plus 1, you should consider this. If the current building's height is greater than or equal to the next building's height, you do not need a ladder or bricks. Like this example, like from the 0 to 1, you just jump. If the current building's height is less than the next building's height, you can either use one ladder, so it doesn't matter what is the height difference. You can use one ladder, or you should use as many bricks as the difference of the two heights. And you should return the furthest building index, starting from 0, you can reach if you use the given ladders and bricks optimally. Okay, I see. And there are some examples. The examples are a little larger than we can review. I will have my own examples later. But take a look at the constraints always. So the height, length of the input is 10 to the 5. So here you should get an idea that you should be looking for some n or n log n solution, because n squared is not feasible here. As a rule of thumb, we have talked about this before, that n squared here is going to be 10 to the 10, almost. And 10 to the 10 is more than 1 billion. And whenever it's more than 1 billion, it's better to consider an improved solution. Heights are from 1 to 10 to the 6, maybe important, maybe not. And we have up to 10 to the 9 bricks, and the ladders is going to be 0, nothing, or less than or equal to the length of input. So how do we think about this problem? This is the question you should always be asking yourself. This is the question you should be asking yourself if you are watching a video, if you are reading a tutorial. You should say, how do I come up with the solution myself? So here, what you can do is you can incrementally extend the furthest building you can reach. So one building at a time. You come here, can I do that? You come to the next, can I do that? You come to the next, and you extend that. This is probably the most natural approach that could come to you, is let me do it one at a time. Let me solve it one at a time. And when you decide to do that, let's go and talk over the whiteboard. So this is the first thing. Let's incrementally extend the first building we can reach, and let's design a strategy for that. And when you want to incrementally solve something, that means you are adding one building at a time, right? So what you should be doing is you should imagine, let me go to the next page. You should imagine that you have solved the problem for 0 to I minus 1. You should imagine that and ask yourself, okay, so far from 0 to I minus 1, what has been the best strategy for me? What has been the strategy so far? And how do you find an answer for this? You can start having some examples. So let me have an example here. Connected. Okay. I'm gonna write the differences because, as we saw in our problem description, when the current building's height is less than the next building, that is when you should decide to use ladder or bricks. So I'm just going to use the height differences that are important to us. So I'm going to write 3, 7, 2, 9, 5, 10, and 11, let's say. Or 10 is enough. Okay. This is the from 0 to I-1. You have handled these height differences. This is an example. And you know that you have 3 ladders, for example. You have 3 ladders. And for example, you have 50 bricks, let's say. Doesn't matter. Now ask yourself, what has been my strategy so far? How did I use my ladders? And if you think greedily, you will come up with the answer that, oh, okay, 1 ladder could be used for 1 brick or 2,000 bricks. It doesn't matter. But using that ladder for a larger number is better because we will use our bricks more optimally. So in this case, 10, 9, and 7 are going to be handled by ladders, and the rest of them are going to be handled by bricks. This is the greedy approach. This is thinking greedy. You're going to say, go back to your question. You have solved the problem from 0 to I-1. You have solved this. That means, and the optimal strategy should have been using the ladders for the three biggest numbers. Okay, now we know what our strategy has been so far. Now you should ask the next question. Having solved from 0 to I-1, let's go here. Having solved the problem from 0 to I-1, we know how we solved that. Now I want to see if I can add index I. What should be my strategy now? What should be my strategy now? Let me see if I can copy this. 3729. 9 and 510. And ladders are 3 of them, and bricks are 50 of them. Okay, and now you want to add 12. Let's say you want to add 12. This is the index I. And so far, you know that you have used ladders on 7, 9, and 10. So keep them somewhere and call them 7, 9, and 10. And these are the 3 biggest diffs so far. So as per our strategy, which we discussed, this is the invariant. This is the invariant. That means this is something that, this is a condition that we should keep as we add new numbers. So that means if we are adding 12, if 12 is among the 3 biggest diffs, we should use ladder for that. And in order to find out whether 12 is among the 3 biggest diffs, we should compare that to the minimum of the 3 biggest so far. So we compare to 12 and 7 and say, okay, is 12 bigger than 7? If that is the case, that means 12 should be solved with a ladder. So what we do is that we say, hey, 7, you leave this set, which is the 3 biggest diffs so far, and I will add 12 here. And that means if I want to extend my current answer to index I should solve 7, not 12. Now I should solve 7. And the question you should be asking is, do I have bricks for 7? Does that make sense? Because having bricks for 7 is easier, is more likely for you to have 7 bricks than 12. And you keep this invariant of your running solution. which is an extension of the previous solution. Like you have solved this up until I minus 1, and now you are adding I. Okay, all right. So and you keep doing this until you run out of bricks. Like until you, like in this example, if you cannot solve 7 with your bricks, if your number of bricks are less than 7, that means you're done. That's it. You cannot do better. And okay, so how do we the only important thing is this one. How do we keep track of the 3 biggest diffs? We can have a min heap. We can have a min heap, and each time we can just get the top. And you can just do a quick search and see in your programming language of choice how you can implement a min heap. In C++, we are going to use a priority queue. A priority queue in C++ is a max heap, but we are going to modify that to become a min heap. That's it. Now we can go and see how we can implement this solution actually. Okay. So first of all, we need the min heap. So priority queue int. I'm gonna call that with ladders. With ladder. So these are the numbers like that have been solved with ladder. And I'm gonna say it's gonna be int, vector int, and greater int. I think that's how you can define a min heap. And then I have an index, and I will take as many of the ladders as for the beginning. To begin, I'm gonna take this number of differences and put them with ladders, because we said if you have solved from 0 to I minus 1, the 3 biggest are gonna be solved with ladders. So if I have solved this problem from 0 to like 3, so I have only used the ladders so far, if I have 3 ladders. So let me write it, it's going to be clear. So while I is less than h.size, so I is going to be 1, okay, and ladders is greater than 0. In diff, I'm going to take diff, it's going to be hi minus 1. So if diff is less than or equal to 0, just continue. But before continuing, we should increment I. So otherwise, add it to our priority queue. That's push diff and get rid of this decrement ladders. Okay. So when we are here, we have used all of our ladders. We have used all of our ladders so far. We have used all of our ladders. So and we have extended as far as we can. Now we should keep going. And each time we want to add a new number, we should do the logic that we just discussed. So we again do the same thing. We take diff. If diff is less than or equal to 0, I++. Otherwise here, we need to compare diff to the top of the priority queue, to the top of the min heap. So if, first of all, if we have anything, so if with ladders is not empty, so if we have anything, then we compare our diff to the top of the with ladders. So if diff is greater than with ladder the top, so if that is greater, that means this diff belongs to the set of our 3 biggest numbers, right? So in this case, I'm gonna say with ladder dot pop. So I'm gonna pop the minimum number. I'm gonna add diff back. So with ladder dot push diff. Okay, and I'm gonna keep this top in somewhere temporary. So int temp, I keep this, and at the end I'm gonna say diff becomes temp. So after this if statement, now the amount that we should handle is equal to temp. If I go back to the whiteboard, okay, if I go back to the whiteboard here, now we have the 7, remember? So 7 is the top of the min heap. So here, the top of the min heap, I keep that somewhere. After I pop and I push diff, I update diff. And now here, I should check whether I can handle diff or not. So if bricks is greater than or equal to diff, that means I can handle it. So bricks minus equal diff and I plus plus. That's it. Else return else brick. And here outside of this while loop that you can see, I will just, let me get rid of this and get rid of this. So here we return I minus 1. That's it. Because I is on some index that is not reachable. So we return I minus 1. Let's try this. Wrong answer. Output 3 expected 4. Output 2 expected 7. Okay. Okay, so what is the problem? Here, I think the second one is better. Okay. Output is 7, but expected is 7, but we are returning 2. How do we fix this? Let's read the code first. That's what I do first. So what we are doing here is first we are, if diff is less than or equal to 0, we just increment I and continue with ladder that push diff, ladders minus. Oh, okay. No. Okay, here again, if it's not empty, let me check this. Okay, the problem was silly. Here, when you are extending here, you should do increment I, and I wasn't incrementing I. This sometimes happens when you are in charge of I. You are using a while loop instead of a for loop. So that's it. And submit. And accept it. So this is the first solution. For the second solution, you can think about this. This is the hint that you can use for the second solution. Return the furthest building. What does that mean? Return the furthest building. That means that if the answer is 9, any number after 9 is not possible. So 10 is not possible. 11 is not possible. So that means from 0 to 9 is yes or is possible. From 10 up to the end is impossible. And when you think about it like this, and if you have solved some binary search problems before, you should get the idea that, oh, maybe I can run a binary search on the answer. And then you think how to solve it from there. Ask me any questions if you have in the comments. I will explain in more details how the binary search solution could work. And thank you for watching.